Hello student, our today topic is dipole moment, and dipole moment is a product of magnitude of negative or positive charge represented by Q and the distance between the center of the positive or negative charge called dipole moment. It is usually denoted by mu, and the mathematical it can be represented by mu is equal to Q and D, where mu stand for dipole moment and Q stand for charge and D stand for distance. The another definition and the simple definition is it is a vector quantity which is a measure of a bond polarity. Girls and boys, measure the bond polarity. It can understand by the easily but through an example. Suppose example HCl. Girls and boys, HCl. There is a single bond between both atoms, and the electrons are not equally distributed between the H and Cl. The electron density is displaced toward the more electronegative element Cl. That's why gain a partially negative charge and hydrogen get partially positive charge. The distance between the pole is denoted by D or called D, right student? And the distance or direction of the dipole moment always toward the more electronegative element and represented by this arrow sign, right? And this molecule is said to be polar, right? If molecule have a multiple bond, in this molecule have a single bond. If any molecule have a multiple bond like this, girls and boys, the direction of the dipole toward the more electronegative elements, and then if molecule have a multiple bond, then the dipole moment is a addition of the vector quantity of both bonds or total number of bonds present within a molecules. Another example के through हम और clear करते हैं student. Suppose these are the examples, right? First example is boron difluoride. Draw the lattice structure of this molecule: boron, then fluorine, girls and boys. The direction of the dipole moment is more electronegative elements. In this molecule, fluorine is more electronegative than beryllium, right? And this direction, girls and boys, the fluorine atoms, there are two atoms towards the opposite direction, that's why cancel out to each other. The total dipole moment mu is equal to 0, right? If the net dipole moment meaning mu is 0, then molecule said to be non-polar, right? Np represented by Np. If the total mu if non-zero, then molecule said to be polar, right student? Next, that's why the BeF2 said to be non-polar, right? Next example, carbon dioxide. Draw the lattice structure of carbon dioxide and also symbolize the direction of the dipole. In this molecule, oxygen have more electronegative than carbon. That's why the direction of the bond is opposite equal magnitude. That's why cancel each other, and the total dipole moment will be 0. And then molecule said to be non-polar, right? So CO2 also non-polar. Next, boron trifluoride. First of all, draw the lattice structure of boron trifluoride, right? This is like this. This is a trigonal planar molecules, and the direction of the bond dipole moment is more electronegative elements like this. The total dipole moment, like a concurrent forces, cancel out to each other, and the total dipole moment is equal to 0. That's why molecule will be non-polar, right? Next example, CH4. Similarly, you can solve this example: tetrahedral structure and cancel out all forces to each other. That's why the total dipole moment will be 0, and then molecule will be non-polar, right? PCl5. First of all, draw this structure of PCl5. The Lewis structure PCl5 will be P, Cl, Cl, then Cl, having a single bond, and another Cl, like this, right? Next, the dipole moment will be directed toward the more electronegative elements, like this, and like this, right? The total net dipole moment is cancelled out, and the value of mu will be 0. That's why the molecule will be non-polar, right? Non-polar. CH2Cl2. First of all, draw the structure of CH2Cl2 like this and this, right, student? C and C. The direction of the dipole moment will be towards more electronegative elements, like this, and hydrogen is less electronegative than carbon. The direction will be toward more electronegative element toward the carbon. That's why the net mu is equal to, it will be non-zero. Cancel out नहीं होगा, that's why non-zero, and then molecule will be polar. So girls and boys, CH2Cl2 will be polar molecules, have a polarity. Next molecule NH3. Girls and boys, in case of NH3, first of all we draw the Lewis structure of NH3 and lone pair H, H, then H. The direction of the dipole moment toward the lone pair, like this, and hydrogen is less electronegative than nitrogen. The direction will be towards nitrogen, like this. Then the total dipole moment will be non-zero, girls and boys. That's why molecule will be non-polar, right? We can say that ammonia is non-polar molecule, right? Another example is nitrogen trifluoride. And first of all, draw the Lewis structure of nitrogen trifluoride. The direction of the dipole moment toward the lone pair of electrons and toward the more electronegative element. The fluorine is more electronegative than nitrogen, like this, right, student? Maybe two maybe cancel out, but two fluorines more attract the electron, and then the value of mu will be non-zero. That's why molecule will be non-polar, girls and boys, right? First of all, most important things, maybe comparisons आ सकती है. Which molecule is more dipole, have a more dipole moment compared to other? Suppose there is two example, NH3 and NF3, girls and boys. Structure भी है, comparison करनी, only comparison. In ammonia cases, the direction of the dipole moments only one side, but in case of fluorine, there are only one direction is opposite, and another three is one-sided, in which the dipole moment, the ammonia molecule is more polar compared to NF3. Why? In case of ammonia, the directions are same in direction, but in case of fluorine, the dipole direction is opposite, right, student? Then we can say that ammonia is more polar than compared to NF3. And last important thing of this lecture, the unit of dipole moment is divide, right, friend? Maybe एक नंबर में कभी कभी क्वेश्चन आ जाता है, what is the unit of dipole moment? The unit of dipole moment is divide. Is that clear, student? Clear हो गया? Any problem? You can freely ask me. Thank you.